This video is a summary of my water infrastructure and resource management project. The subject code is also known as WRM 3701. It is for semester 2, 2022. It is presented by myself, Joanne Correa, student number 629333590. The scope of the project was for me as an engineering technologist to make an analysis of water supply project to be implemented by the Tishipi local municipality. This project is intended to provide a water supply to 5 townships in line with the Water Services Development Plan. A general layout of the community was given along with specific criteria and requirements that need to be implemented as part of the design. I used EPANET, which is a readily available computer software that allows engineers or researchers the chance to run simulations of water supply networks which display practical and realistic results. My final simulation resulted in the one seen on the screen above. The results obtained for the pressure and diameter. For pipes 1, 2, and 5, this is from the reservoir to the junctions and from the main junction to the other 2 junctions. This is the pressures I achieved. It was 378, 139, 239 respectively. The diameter sizes for these is 450, 400, and 500. For demand centers 1, 2, 3, 4, and 5, we were told to have a specific liters per second, as that is the average daily demand that each demand center requires. I obtained 66, 73, 84, 84, and 70, which is above the average daily demand. These diameters include 350, 400, 300, and 350, 350 respectively. The velocity obtained are as follows: 2.38, 1.11, 0.69, 0.58, 1.22, 1.2, 0.87, 0.73. From pipes 2 to 8, I can see that they fall within the bracket, which is below 1.5 meters per second, which was the required criteria. However, for pipe 1, which is from the bulk storage reservoir to junction 1, the velocity is 2.38 meters per second. This is above the requirement, thus the simulation actually fails. For the head losses, the criteria said that the head loss needs to be less than 10% of the available head. The head loss for pump 1, which is from the river to the water treatment plant, was at negative 22 meters, and for pump 2, which is from the water treatment to the bulk storage reservoir, was negative 35 meters. Through the analysis that I have learned that the diameter of the pipes affect the pressure and velocity. And this also showed me how changing the diameter will also allow the water being supplied to overcome resistance, such as at pipe 8, I noticed that from reservoir 7, it is higher than the elevation of the junction that is supplying it. This needed a smaller diameter pipe so that it could overcome that to get the desired pressure and velocity. I also have to take into consideration the pumps. Pump 1 was placed between the river and the water treatment plant. This was due to the fact that the water needs to be pumped from the river to the water treatment plant, thus requiring the pump. Pump 2 needed to be placed between the water treatment plant and the bulk storage reservoir, as the bulk storage reservoir is at a higher elevation than the water treatment plant. Thus, the water has to overcome the great height difference. In conclusion, I think that my project was a success, as all but one requirement was met. The only requirement was that the velocity for pipe 1 was much higher than the criteria stated. The experience I gained from creating my own water supply network and having to apply theoretical knowledge into a practical component allowed me to understand the topic of hydraulics and water supply in greater detail. Thank you for listening to my summary of my water infrastructure and resource management project.